laparoscopic findings. And some of the interesting and somewhat less commonly known findings are ones such as this, the so-called Allen-Masters syndrome, as it's referred to, at least in the English literature, which are defects in the peritoneal surface. And in this particular case, that's quite a large peritoneal defect, but it's been suggested that there may be subtle defects in the peritoneal surface, the mesothelial surface of the peritoneum, that might actually predict a little bit the presence of endometriosis. And here's an example of what is being proposed to be very, very early changes associated with endometriosis in a paper by Bruce Lessig. I may show you another paper from his group. He's done lots and lots of work in endometriosis. But here he's using the vital dye methylene blue, diluted at the time of laparoscopy, to stain the peritoneal surface. And in panel E above, this is what the laparoscopy looks like without any methylene blue. After about 20 minutes of exposure to this methylene blue dye, it stains the tissue, the extracellular matrix that underlies the mesothelium. And we believe it's probably representing very subtle defects in the peritoneal surface. So this could be one of the early signs of endometriosis development, and maybe one of these laparoscopic adjuncts, such as methylene blue, could be used in cases where it's too subtle to be able to be visualized the way we normally do with laparoscopy. So in the 40 years that I've been involved in sort of thinking about endometriosis, we've moved from a very kind of classical ideas about it, which were frankly pretty surgical in terms of their thinking, that endometriosis was problems associated with it were caused by tubal occlusion, anatomic distortion, adhesion formation. But in the last, several decades, we're becoming more and more sophisticated about biochemical and molecular aspects of endometriosis, the recruitment of immune cells, activation of cytokines that are important, and kind of ideas of angiogenesis and even neuroangiogenesis, the growth of blood vessels and nerves into these endometriotic lesions that might actually allow them to develop. And if we think about endometriosis that way, we can think more about sort of medical types of therapies that could be used to help women and maybe even prevent the development of endometriosis in young women. So those are some of the kind of classical and I'd say neoclassical approaches that we're trying to take in this. So as we've mentioned throughout today, we know that these two steroid hormones are very, very important in the regulation of the endometrium and the growth of endometriosis and endometriomas. Estradiol promoting a lot of inflammatory changes potentially, causing the cells to proliferate and grow, and for nerves and blood vessels to grow into them. And progesterone, on the other hand, is more important as an anti-inflammatory agent. It causes differentiation, residualization of the tissue, and allows it to potentially heal. So these have been the two strategies that we've used for medical therapies for endometriosis. And this, the GnRH agonists and the whole discovery of GnRH was really kind of critical to our work in vitro fertilization and also in endometriosis. And this shows Roger Guillemin and Andrew Schally, who shared the Nobel Prize in 1977 for the discovery of that really quite simple 10 amino acid peptide, GnRH, that's so important for reproductive function. And I've shown up above where the little blue arrow is that this is a protein, a peptide that's very susceptible to proteolytic cleavage and inactivation, and that's why it has such a short half-life. And that very short half-life is what allows it to pulse up and down, as Sarah showed you in the slides. The sampling that she did as a fellow, drawing blood every 10 or 15 minutes from women to show the pulse top pattern of GnRH. So we know that GnRH regulate pituitary function, ovarian function downstream of that. And this has been one of the major approaches for endometriosis medical therapies. So the kind of the chemical structure of the GnRH decapeptide, those 10 amino acids is shown in the upper left. Once we knew which amino acids were important for metabolism, we could make substitutions of those amino acids that made for superagonists like leuprolide, ultimately antagonists. And now there's a whole new class of small molecules, not peptides, but actually orally available GnRH antagonists. And the one that's currently on the market in the United States, at least, is elagolix. But there are others in other companies that are under development, at least 2 other compounds that are very close to commercialization. So I think these will be interesting new compounds that we have and will have available to us. Now, I will say that the actions of these are likely to be quite similar to what we know about with kind of current agonists and antagonists that we have. So with agonists, we know that there's initially a stimulation of ovarian function, and then with a superagonist like leuprolide, there's downregulation of the receptors in the pituitary and ultimately endometrial atrophy and reduction of steroid hormone production. With antagonists, there's a sort of a direct inhibition, so there's no flare effect, there's a direct inhibition of gonadotropin release and downregulation of the ovary. So these are going to be the kinds of, at least one sort of family of medications that will be used in a way to try to suppress and prevent endometriosis from growing. So, if we try to get back now to think a little bit about what is the very early lesion of endometriosis, what does it look like? Well, we know that actually if we do laparoscopy in a pediatric or adolescent patient population, as Ann Davis did back in the early 90s, they found that these kind of red flame-like hemorrhagic lesions were the most common. And Jacques Bonnet and his group also suggested that after endometriosis implantation, that early development of these have this very kind of red vascular appearance. And our own group was quite interested, and we thought that these red lesions were really reflecting the flow of blood that comes into these lesions as a result of angiogenic factors like vascular endothelial growth factor and fibroblast growth factor, angiogenic factors that we know are important in actually endometrial vascularization at the time of implantation, endometrial cancer, other cancers, this sort of activation of vascularization is really critical. Now, actually, interestingly, John Sampson, who was really the American surgeon who was one who was early in proposing this idea of retrograde menstruation, some of his very early drawings from the 1920s actually look a little bit like the kind of early lesions that we sort of are conceiving today. And this is really quite compatible with the idea that viable endometrial fragments, viable endometrial tissue that flows reflux direction through the fallopian tubes into the peritoneal cavity and falls on these peritoneal surfaces might be the very first early kinds of lesions that initiate the growth as a result of this vascularization. Now here's some cartoons actually from Professor Donet's article, actually sort of depicting how these little fragments of endometrium would fall into the peritoneal cavity and start to form the early lesions and kind of attract this vascular supply. So we believe that the kind of ingrowth of blood vessels will allow these, a little lesion to sort of grow into a larger, more fibrotic lesion, as has been shown quite demonstrably in cancer development. So for a cancer metastasis to grow and proliferate beyond 1 or 2 millimeters in size, it really has to co-opt and attract a new blood supply. and we think the same process is going on with endometriosis. So this is a little cartoon suggesting a fragment of endometrium falling onto the peritoneal cavity. The little red dots there are signals that that tissue is sending to recruit a new blood supply, and then new blood vessels grow in to allow that to grow into a lesion. And we think actually it may be more than just blood vessels. You'll remember if you had the experience that I did as a first-year medical student of trying to figure out this complicated neurovascular brachial plexus anatomy, and I've always been kind of impressed at how integrated the growth of blood vessels and nerves are. Vesalius, actually, several years before me, had made the same observations showing the sort of similarity of the nerves and the blood vessels, and you can see in the micrograph on the right the sort of close association of those nerves and blood vessels. So the ability of these early lesions to grow may be that they're able to kind of adapt to this ability to get nerves and blood vessels to grow in to actually help that lesion proliferate and also start to send signals, potentially pain signals, back to the host. So it's very difficult in clinical studies to follow the progression of endometriosis. It would require doing multiple repeated laparoscopic procedures. Sometimes that happens in some of our patients who have recurrences and require those procedures, but this is another kind of way of trying to understand that. So Azmi Fazilabas's group has been working for many years using a baboon model of endometriosis, where they take the menstrual tissue from the baboon and actually inject it into the peritoneal cavity in anesthetized baboons 1 month, and then the subsequent month, and then follow those animals laparoscopically every month. And you can see that there's a kind of a tendency here in the bottom are the different kinds of lesions: red lesions, black lesions, blue-colored lesions. But what it demonstrates is even at the time of the second month of inoculation of endometrial tissue in the peritoneal cavity, there are a lot of these red lesions. And over time, those red lesions tend to go away as the animal's endometriosis develops. The percentage of red lesions go away, and those lesions appear to kind of evolve into black lesions or blue lesions. So we think that this is, again, another bit of evidence from now a primate experimental model system that the early lesions might be these very vascular red-like lesions, and over time they evolve into more complex endometriosis lesions we tend to see more clinically. So if we believe that, and this is obviously a little bit of a circular argument here, but retrograde menstruation is at least one of the mechanisms that these endometriotic lesions arise from. Those will grow in the peritoneal cavity, and they actually can secrete proteins like brain-derived neurotrophic factor, a protein that stimulates nerve growth, or vascular endothelial growth factor that stimulates vessel growth, and sort of attract this neurovascularization, what we call neuroangiogenesis. And the nerves, at least, we think are really important in terms of pain. One of the other things that we know that those endometriotic lesions do is they incite an inflammatory response and recruit macrophages. So macrophages play quite an important role. They are kind of attracted to the peritoneal cavity. They can be fairly angry and are making cytokines and things of their own. And we think that interleukin-1 beta, kind of shown there in the purple, is one of the important ones that have both effects on pain and also on infertility through some of the effects that I talked about this morning, inhibitory effects on endometrial development. So we think that all of these processes kind of work in a feed-forward pathway over time to generate more and more lesions and more symptoms, which is typically the way women with endometriosis will present. Now, here at the end, I just wanted to talk about some of the ways that we're thinking about some of the molecules and the pathways that they're utilizing. So in these studies, we've taken endometriosis cells that we grow in the laboratory, and we can stimulate those cells with interleukin-1 beta. Again, this is one of our favorite cytokines. It's a product of those macrophages. The macrophages secrete a lot of that particular protein. And in the upper bands, you can see that as we increase the dosage of interleukin-1 beta that we expose the cells to, we start to see more and more of this brain-derived neurotrophic factor, this nerve growth factor that we believe is responsible for pain and the nerve growth associated with endometriosis. And one of the ways we think that that works is through this pathway called the nuclear factor kappa B pathway, NF-kappa B pathway. And that's kind of shown on the right side of the slide. So these proteins live in the cytoplasm of the cell as a complex of 3 proteins. If they're phosphorylated and activated, one of the proteins, the red inhibitory factor, actually is degraded, and it allows those 2 green proteins to move into the nucleus where they will actually bind to the DNA and activate gene expression. And one of the genes that they turn on is this BDNF gene. So we think that interleukin-1 can actually activate BDNF, as it's sort of shown in the second lane, and that can be blocked if we actually use an inhibitor to this NF-kappa B pathway. So that's kind of what the biochemistry is. How could that be important? There are a whole lot of drugs that have been developed over the years for many different purposes that seem to have activity on this NF-kappa B pathway. And because it's so challenging for new pharmaceutical companies to get into new drug discovery, we're interested in the idea that maybe some of the older drugs that have already been developed might have activity to either improve or potentially prevent the progression or development of endometriosis. And this is a very long list, and I've just listed a couple, but some of them are really quite interesting. So digitoxin is the cardiac glycoside drug. I mean, I never would have predicted that this is a drug that would have effects on the NF-kappa B system, but it's actually fairly potent in inhibiting NF-kappa B. So it's possible that rather than discovering a new GnRH antagonist or something like that, it might make sense for pharmaceutical companies to focus on things that are already available. So digitoxin is one example. Teoconazole is a drug that we all use in gynecologic practice as an antifungal drug for yeast vaginitis. So some of these drugs might be repurposed. We might be able to use them in different ways. And then there's some chemotherapeutic drugs. Sunitinib is used in renal cell carcinoma, and it inhibits tyrosine kinase receptors. Probably has a side effect profile that we wouldn't be so happy about, but the concept that there may be some drugs that are already in existence could be studied in endometriosis, I think, is an important one. And then there are a lot of natural compounds. And I mentioned a little bit earlier, one of our favorites is curcumin at the very top, but there are lots of different natural compounds that maybe young women, 14, 15 years old, might be able to sort of tolerate taking for years and years and years if we do come up with protocols that can sort of prevent the progression or the development of endometriosis. And a number of these compounds have been shown to have inhibitory effects on the NF-kappa B pathway. So at least in terms of thinking about the future, maybe some really old drugs could also be useful in the future. Again, this is turmeric as an example of one of those, and one that we've had the opportunity to study a little bit in the laboratory and in some animal models. We haven't done clinical trials yet, and I should say that the real spice is not very biologically available, so when you eat that, it's not very well absorbed, so we might have to do some modifications to make that a better drug. So to summarize then, we think that the new early implants of endometriosis are typically these red flame-like lesions that have a prominent neuroangiogenic component to them. And 2 of the growth factors that we're interested in are the brain-derived neurotrophic factor, which those lesions make a lot of, and also vascular endothelial growth factor. The early superficial lesions should be quite easily treated by surgery, but they also might be amenable if they're kind of small and haven't become really well established to be inhibited or potentially prevented with medical therapies. The FDA-approved medications that we have currently are all focused on hypothalamic pituitary ovarian axis, resulting in suppression of ovarian hormones. It does suppress the growth of the endometriotic lesions, but it causes osteoporosis and hot flashes and mood changes and potentially sort of increased cardiovascular risk. So these are things to think about. Trying to identify drugs that are outside of that axis, maybe anti-inflammatory compounds is kind of more of our thinking. And then maybe repurposed pharmacologics, so old drugs that we've developed new indications for, might be useful, and we believe that this NF-kappa B pathway is an important pathway that we kind of consider for doing future clinical trials. So with that, I'm happy to answer any questions.